Greetings, students. So we're going to talk about a way to solve a quadratic. The first few that we do, we could solve with factoring, but that helps us recognize that this formula does give us the same solutions as we would get if we factored. All right, so you might think, this seems like so much work, why wouldn't I just factor? Yes, exactly. If it comes out nicely, we would say, why wouldn't I just factor? But I'm trying to give you some practice using the formula when the answers are pleasant, because then we're going to have some answers which are not pleasant. And we're going to use our simplifying radical skills to simplify those answers. So let's start off with this first one. Remember that standard form for a quadratic. We should review that, because if it's not in standard form, you're going to be using the wrong numbers in the wrong places. So standard form for a quadratic, remember, is when we have ax squared, and then we have plus bx, and then plus c, and it's set equal to 0. A, B, and C will be numbers. They may even be negative numbers, so if there is a negative sign, you need to consider it to be part of that coefficient or constant. We typically write it in this order. It makes it very easy to identify which one is A, B, and C. Keep in mind, if it's also important, though, that the A is the one that is the coefficient of x squared. The B is the coefficient of x. So if there is no x, no regular x's, no x to the first power, then B would be 0. And then C is a constant. And we need to identify these numbers after the equation is set equal to 0. If we try to identify it before it's equal to 0, it's not going to be helpful because the signs might not be right, or we might have more than 3 numbers. Okay? So this first one is already in standard form. Step 1, check, check, is done. Then we want to identify what is A, B, and C. And after you've done a few, it may not be something that you write down, but at first, at least, I'm going to model writing that down just so that it is very clear. So A in this case is 1, B is -5, and C is -6. From there, we just put it into the formula and simplify. Now, kind of sounds easy, and a lot of it you could put in the calculator at one time. Once you get the hang of it, that process is not bad, but you have to know how to use the tools that you have, and you have to be careful because there's lots of parts, right? So the x is going to be equal, remember we're solving, to, you see the formula over there, negative b. So at first I'm going to write, there's a negative in the formula, and then b actually is -5. Actually, let me try something here. So b is -5. So everywhere when I'm plugging in -5, I'm going to use blue to try to help you see what I'm doing. And so it's -5. The negative on the outside is part of the formula. Plus or minus could be positive or negative. We'll deal with that. That's what that means, though. And then big square root sign, again, part of the formula. On the bottom part of the formula is that we're going to take 2 times a. Also part of the formula, we're going to take the b and we're going to square it, and we're going to subtract 4 times a times c. In fact, I usually think of this part, -4ac, not really as subtraction, but that I'm multiplying -4 times a times c, And then positive or negative, that's going to get combined with the b squared. So where I've put all those little blanks are all the things that are b's. So b's, I put one of them in already. Negative 5 goes here. And then where do I have a's? Well, I have an a up here, and a is 1 in this case. So all of my a's I'm going to fill in green. Here's an a, here's an a. So they're 1s. So that was this one and this one. And then I also use the C number. So for C, to help you follow where I'm going, I'm going to use purple. So C only gets plugged in one place, and it is negative 36. I might have written that a little small. That's not so bad, I guess. All right, so now I have plugged in all the A, B's, and C's into the formula. Now I need to start simplifying this. And no, I would not try to type all that into a calculator, but maybe all of it that's under the square root. But here on the outside, negative 5, so it's like the negative b is like saying the opposite of b. So that becomes positive 5 plus or minus, and then big square root. Now, you might do this whole part under here. This part has a name, it's called the discriminant. But that whole part underneath, you might type that all in the calculator at once, or you might choose to do it in a couple steps. Negative 5 squared is positive 25. And then negative 4 times 1 times negative 36. I like to settle my signs. I have two negatives in that string, so I know it's going to become positive. And then 4 times 1 is 4 times 36, 144. In the denominator, 2 times 1, that's easy. That's just 2. And then in the top, x is equal to 5 plus or minus, this is the square root of 169 over 2. Well, the square root of 169 is 13. Yes, it's a nice perfect square. So this is where, when we find the square root, we're going to split it into a plus situation and a minus situation. So then I could say that x is equal to 5 plus 13 divided by 2. X is also equal to 5 minus 13 divided by 2. If you were in class when I first went over this, I encouraged people to use paper because there's not a lot of space, particularly on the notes. There's a little more space on the assignment page, but there's not a lot of space. And then 5 plus 13 is 18. 18 divided by 2. One of my solutions is x is equal to 9. My other solution, 5 subtract 13, or 5 minus 13, is negative 8. Divide that by 2, and I get x is negative 4. So those are my two solutions, 9 and negative 4. And if you remember when we factored, this would have factored. So if I had factored, I would have had x minus 9 and x plus 4 is equal to 0. That would have meant x is equal to 9, x is equal to negative 4. So those are the same two solutions that we would get from factoring. So I realize it looks like a lot. I'm going to skip down to some where there's more work to do than just use the formula, because we will still use the formula also. All right, I went down to number 2, and you will see that I've given myself lots of room. I realize you can't do that on a piece of paper, so please feel free to get a sheet of paper if necessary. So first off, look at your checklist at top, and first thing is make sure it's in standard form. This is not in standard form because it's not equal to 0. So the 12, he needs to move over so that that can become 0. So now I have 2x squared plus 7x subtract 9, or negative 9. Now it's equal to 0. Now I'm going to identify my a, b, and c. So my a is 2, my b is 7, and my c is negative 9. Okay. So I have my a, b, and c. So my quadratic formula, x equal negative b. Also, you will not be required to memorize this if you're a little worried about that. Plus or minus square root of b squared minus 4 times a times c, all divided by 2a. So x is equal negative b is 7, so negative 7. Right? I plugged in the 7, the negative sign was already there. Plus or minus 7 squared minus 4 times 2 times negative 9. All of it's going to get divided by 2 times 2. Or if you prefer, you can use the parentheses there to kind of show you're plugging something into that. So sometimes that helps people to just think like I'm plugging into those spots. So all of these were things that I plugged into. So this is negative 7, square root of our 7 squared, under my square root sign, 49. And you could just write 49 to start with. You know 7 squared is 49. That's okay. And then negative 4, I've got 2 negatives, again, in here. So it is going to be minus. And then I can just focus on 4 times 2 times 9. So 8 times 9, or I'm sorry, it's not going to be minus. Whew, plus 8 times 9 is 72. Whew-wee. 2 negatives make a positive when I'm multiplying. And then in the denominator, 4. Everybody makes mistakes. Everybody has those days. But I caught it, so at least I didn't lead you astray. So then 49 and 72 is 121. Now, if that 121 was not a perfect square, then we might end up with an answer that looks just messy like this, or a radical that we can simplify. But because it is a perfect square, then this is going to, when we take the square root, this is going to split into 2. So I'll have x is equal to negative 7 plus the square root of 121 is 11. That's going to get divided by 4. Also, x is equal to negative 7 minus square root of 121, still 11, divided by 4. If you use the calculator to get this last part, be sure that after you add, you hit equal before you divide. If you do not do that, the calculator will assume that you're following order of operations, and it will do the division first. So that's not what we want to happen. That big fraction bar is a grouping symbol, even though we don't show it as a grouping symbol. We want to be sure to simplify the entire top, get 4, and then 4 divided by 4, x is equal to 1. On the other side, negative 7 minus 11 is negative 18, also divided by 4. So here we could give the answer as negative 9 over 2. or negative 4.5. I don't mind the decimal as long as the decimal is nice and neat, right? But I do not want you to round. If it would mean rounding, then I want you to go back and use a fraction. But if it comes out, 0.5, 0.25, that's fine. All right, so there's one where it's not just a 2 in the bottom because it is 2 times a. We do have a lot of times when it's only 2 in the denominator because if there's no leading coefficient, but here there is a leading coefficient. All right, we're going to look at another one. The next one we're going to look at does not have it does not have an A, B, and C. All right, I've gone to number 4, and again, we need to make sure we get it set equal to 0 first. So we're going to subtract the 6x, get it over there on the same side. He does have someone to combine with, so we should do that. So I end up with plus 9x equals 0. So here, A is 1, B is 9, and C is 0. We don't have a constant. And now we're going to plug those things into quadratic formula. If you want to just give yourself a little challenge and put me on pause and then see if you put things in the right place, feel free. So remember quadratic formula, you should have written down negative b, so negative 9 plus or minus b squared, which in this case is going to be 9 squared, negative 4 times a, which is 1, times c, which is 0, right? C is 0 in this case. All divided by 2 times 1. So I have negative 9 plus or minus the square root of, well, this is just going to be 81. If a or c, which you won't have one where a is 0 because then it wouldn't have an x squared, if c is 0, then 4 times 1 times 0, 4 times anything times 0 is 0. And 81 minus 0 is just 81. Divide by 2. So then I'm ready to take the square root. So I have negative 9 plus 9 divided by 2. And I also have x is equal to negative 9 minus 9 divided by 2. So on the left, negative 9 plus line, that's 0. 0 divided by 2, one of my solutions is x is equal to 0. On the other one, negative 9 minus 9, that's negative 18. Divide by 2, x is equal to negative 9. So those are my two solutions. And remember, these first ones, if we're getting nice answers, it means this could be, you could check it easily with factoring. X on the outside, right, common factor, x plus 9 is equal to 0. That means either x is 0 or x plus 9 is equal to 0. So there's a solution, and when I take away 9, x is negative 9 is another solution. Same solutions. Again, if you were just given a choice, if you could factor, that's the choice I would take. All right. If you have to do a problem with quadratic formula, but it also could be factored, it's a great way to be able to quickly check your answer. You can also check your answer, check your solutions by plugging the numbers in and making sure that they work in the original equation. So if I would do 0 squared plus 15 times 0, does it equal 6 times 0? Well, that's a whole bunch of zeros, so the answer is, of course, yes. What about negative 9? Negative 9 squared plus 15 times 9, times negative 9, my bad, should equal 6 times negative 9. Well, negative 9 squared is 81. 15 times negative 9, what is that? Let's see, negative 135, I believe. Yeah. And then on the other side, 6 times negative 9 is negative 54. And if I do 81 subtract 135, I do get negative 54. So you can plug your solutions into the original equation. That's also a valid way to check. Always, right? It's an equation. Now, doing the check when we get radicals, they are not so easy to check. But when we have nice, pleasant numbers like this, rational numbers, then the check is manageable. All right, I'm going to go to another problem, but the next one is going to have not a perfect square under the radical. So the discriminant will not be a perfect square on this next one. Alrighty, here we go. Here is, we're going to have irrational solutions now. This is still a quadratic formula. And so we are still using quadratic formula. So I would say if it would be helpful to you, it would be helpful to me when I didn't know it by heart, to go ahead and rewrite quadratic formula, copy that over from somewhere else in your notes or where I'm writing it here. So remember, all the A's, all the B's, all the C's will get filled in with a number that we identify. The signs and the 4 and the 2 are always going to be there. All right, so here we're already in standard form. A is equal to 1, B is equal to 4, C is equal to 1. There is no way I could factor this because there are not two numbers that multiply to be 4, or multiply to be 1 and add up to be 4, right? So I can't multiply to be 1 and add up to 4, so it does not factor. This is why quadratic formula is necessary, right? Because there would be these things that we can't solve. Irrational solutions means that these are numbers that can't be written as a fraction. All right, so they're not going to be whole numbers. They're not even going to be perfect fractions. There's going to be something left under the radical that we cannot simplify. All right, so that's why they're in this section. So we get to use the skills from the first lesson in this unit. So x equal negative b, so negative 4 plus or minus, and then my square root sign, 4 squared minus 4 times 1 times c, let's see, times 1 again. There we go. I had myself thrown off with all those ones. Lots of 4s and 1s there. And then 2 times 1. So negative 4 plus minus. And then again, you may just do 4 squared minus, that's just going to be minus 4, right? So 16 minus 4, this becomes 12, right? Now I just told you how I did that. 16 and then 4 times 1 is just 4. So 16 minus 4. And then in the bottom, 2 times 1 is 2. And I didn't need to make that so long since I did some of that work. Now, if you try your calculator to do square root, 12 is going to be a big messy decimal, right? So the square root of 12 is not rational. But we can simplify that sum. And so if I want to simplify that sum, then this is where we do square root of 12 and break it down with a perfect square. So the square root of 12 is the same as 4 times 3, and the square root of 4 is 2. So I've got 2 radical 3. So this square root of 12 is going to get rewritten as plus or minus 2 radical 3 over 2, and sometimes that's finished. In this case, if those things can all be reduced, we need to simplify. And in this case, the 2 in the bottom divides equally into both of these, so I need to do that to finish. So negative 4 divided by 2 is negative 2. 2 divided by 2 is just 1. So our final answer here looks like this. Sometimes, like if that had been a 5 in the bottom, wouldn't be a 5 I guess, but if it had been something that didn't divide into those, then I could just stop, but in this case it could, so I need to. Alright, let's look at number 10. You can rewind, go back over that as you like, but basically you do not, to simplify, you do not need to be able to divide by the radical, but you do need to be able to divide both of those numbers that I highlighted. Alright, let's go ahead and look at number 10. And of course, the same things still apply as far as if it's not equal to 0, you need to get it equal to 0. So in number 10, you won't often see one like this where the a is negative, but we can still use the formula. A is negative 1, b is positive 2, or I'm sorry, negative 2, and c is 7. I should probably call it quits for today. Oh, so here we go. X equal, now, negative b. So the opposite of negative 2 is going to switch that negative b to being positive 2. Plus minus, and then my square root, b squared. Negative 2 squared becomes positive 4. If you're using the calculator, be sure you're putting it inside some parentheses. But we know signs are the same, answer's positive. Minus 4 times a, right, times c. So negative 1 and 7. And then 2 times negative 1 in my denominator. So 2 plus or minus, now I have 4, 2 negatives, so this is 4 plus 28 over negative 2. So I have the square root of 32 over negative 2. 32, then, I need to simplify that radical. It's not a perfect square, but I can simplify. And remember that you want to go with the biggest perfect square. So 4 and 8, 4 is a perfect square, but there's another 4 in the 8. So 32, I'm going to think of as 16 and 2. So the 16 is a 4 on the outside, because that's the square root of 16. And then a 2. Notice also when we do these ones that we don't get rational answers, we don't have to like split up the plus and the minus. We can just leave it together. So I've got 2 plus or minus, and then instead of 32, now I'm going to write 4 radical 2. And then I want to see, can those be divided by negative 2? And of course they can. And so 2 divided by negative 2 is negative 1. Now you might be like, oh, this is a negative 2, but this is really like there's 1 plus and 1 minus. So just think 4 divided by 2 is 2. You don't want to put plus or minus negative 2 times square root of 2. The negative sign just ends up being that the positive is now the negative and the negative is now the positive. And so that is what our solution would look like. I know it doesn't look like much of a solution at all. That's what it looks like when it is an irrational solution. Right, so give me a minute and I will show you one more of those. All right, if you go to the homework page, number 8 on page 12 in your packet, at least it was page 12 when I'm recording this, if you look at this page, something additional is going to happen in this case. So I don't necessarily need to move things around. Personally, when I was taught, we did always make the x squared positive, but the result is going to be the same. So I don't want to get super caught up in that in case you just went ahead and tried it in the order that it is, since it is set equal to 0. So here I would say x equal opposite of b, so -7 plus or minus, here's my square root, b squared, so 49 minus 4 times -1 times -18. All of that divided by -2. So, in that radical now, when I do -4 times negative, this ends up being subtract or minus. We get a negative number from these three, because there's 3 negative signs, right? And that's -72. Now, that might not seem like a big deal to you, but for our other problems that couldn't be broken down, they weren't perfect squares, if we put them in a calculator, it at least gave us a decimal. But if you try to do this in a calculator, it's going to give you an error message, because there aren't actually square roots of negative numbers. Like, what could I multiply together, the exact same numbers, and get a negative? If the signs are both negative, it would make a positive. So negative numbers don't have real number answers for square root. So there's an imaginary number. You're going to learn lots more about it in Algebra 2. But the square root of -1 is an imaginary number that we refer to as I. I know, it's like magical, right? Again, you're going to learn lots more about it. This is just to introduce you, and my apologies that in 2023, in May, I was not really here to talk about this with you. So, we will. So this, while it doesn't have any perfect square factors, I'm really supposed to think of it as being -1 times 23, and then that just becomes an I on the outside and 23 on the inside. So if you tried to check your answer with something and you're like, I don't know where this wacky number is coming from, so I end up with -7 plus or minus I on the outside, 23 on the inside. 23 doesn't otherwise break down. And then this is -2. Here's another thing. Because these two are both negative, I should make this positive. Kind of like the whole 2 negatives in a fraction. So that's also the reason why typically it's better if your x squared is positive, so then you don't have a negative denominator, because you have less simplifying to do if that is the case. So then I'll make this. So I is an imaginary number that's equal to the square root of -1. It's imaginary because there's no real number that is true for. So just a little bit more about I. If we had something like the square root of -4, well, the square root of 4 is 2, but because of the negative sign, we would say 2i. That's how we deal with a negative under the radical, is we kind of pull that out because it's the square root of -1. All right. Well, I hope that even just a few more examples that is helpful, and I will see you soon.